All right, so let's go ahead and get started here, Hunter, on the homeworks. So looks like what we're going to be attacking today is the reciprocal trigonometric functions. Now, these are really awesome. So let's see. We have trigonometry deals with triangles, right? So let's draw this triangle. Here's theta. Now, we know that this is the hypotenuse right here. This is the opposite side, and this is the adjacent side, right? Now, we've defined the sine of theta to be equal to the ratio of the opposite to the hypotenuse. And we're talking about lengths, side lengths here, right? We define the cosine of theta to be equal to the adjacent over the hypotenuse, and we've defined the tangent of theta to be equal to the opposite over the hypotenuse. Now, there's some other ratios we could come up with. After all, I mean, this isn't all of them. What about the ratio of the hypotenuse on top, for example, hypotenuse on top to the opposite? You know, we haven't included this ratio in our list of trigonometric functions yet. So it turns out there are more than 3 trigonometric functions. There are 6 trigonometric functions. Sine, cosine, and tangent are, well, I was going to say they're the basic ones, but they're not any more or less basic than the ones you're about to learn. They're just different. So we're going to learn cosecant, which is spelled C-S-C, cosecant. If you write it out, it's cosecant. This is the cosecant of theta is defined to be the hypotenuse over the opposite side. Okay? So now we don't have the hypotenuse on the bottom, now it's on the top. We have the opposite over the hypotenuse. Okay? Now we have another one. This one's called the secant. This is denoted SEC, and the secant of theta is going to be equal to the ratio of the hypotenuse to the adjacent side. All right, now there's one more. This one's called the cotangent. This is denoted COT, and the cotangent of theta is equal to the ratio of no, I messed something up over here. Take a look here. I messed this up. This should be opposite over adjacent, shouldn't it? Yeah. Okay. All right, so the cotangent of theta is defined to be the adjacent over the opposite. Now I want you to notice something. I wrote them down in this way on purpose so that you can see this relationship between the cosecant and the sine. Check out the relationship between the cosecant and the sine. Isn't one of them just the reciprocal of the other? Here I have the opposite over the hypotenuse, and if I take the reciprocal of that, I get the hypotenuse over the opposite. So interestingly, they are reciprocal functions. More specifically, the cosecant CSC, cosecant of theta, is equal to 1 over sine of theta. Now take a look at secant and cosine. The secant and cosine also are reciprocal functions. Check that out. Pretty cool, huh? Pretty slick. So in this case, the secant and the cosine are reciprocal functions. And the same applies for cotangent and tangent functions also. All right, that's not too bad. That means we can figure out what the cosecant of an angle is if we know what the sine of an angle is. We can figure out what the secant of an angle is if we know what the cosine is. All we have to do is take the reciprocal, right? All right, so let's attempt problem number 1. This ain't too bad. Let me just make some room here, delete all this junk. Maybe you want to take a look at it and pause the video and write that down. All right, so now that you've written that down, or I hope you have, now let's do this problem here. Problem number 1, the cosecant. The cosecant of 7 pi sixths radians. Alright, this ain't too bad. Now we just have to remember what the heck is 7 pi sixths radians. Well, let's think about our unit circle. So here's my unit circle. Here's 0, here's pi, here's 2 pi, right? So if I go around in sixths, well, after 6 sixths times, I'll get to 6 pi sixths, which is just pi, and then one more 6 should get me to 7 pi sixths right here. All right. So what the heck is the cosecant of that angle? Well, let's draw this triangle. Here's the angle theta, right? The angle theta. Now, of this triangle, do you remember from the unit circle what its dimensions are? Well, obviously the hypotenuse is 1. And if you remember correctly, I think this should be negative square root 3 over 2. And this one is going to be 1/2. Double check me, but I'm pretty sure that's right. If so, then the cosecant of theta is going to be defined by the, well, it's the reciprocal of the sine. The sine of theta is going to be equal to the opposite over the hypotenuse. So the cosecant is going to be hypotenuse over the opposite. In this case, the hypotenuse is 1. That's always the case. And the opposite is going to be this guy right here, which is 1/2. So let's put in 1/2 right there. 1 over 1/2. Now, do you remember how to divide by fractions? All you do is you multiply by the reciprocal. So in this case, the cosecant of 7 pi sixths is 2. Nailed it. Hope you can figure that out by yourself. If you are lost, and go back and watch this again and follow it again. But since I am not with you, I don't know if you're lost or not. So I'm just going to go on to the next problem. All right. Let's see here. Let's make some room. Okay, cotangent. Cotangent of negative pi. All right. Let me just remind myself what cotangent means. The tangent of theta is equal to the opposite over the adjacent. So the cotangent of theta is going to be equal to the adjacent over the opposite, right? So now let's draw our unit circle to figure out where negative pi is. You may already know. All right, so here's my unit circle. Here's 0, here's pi, here's 2 pi. How do I get to negative pi again? Well, this is in the positive direction, so let's actually go in the negative direction. If I go in the negative direction, negative pi should get me here. Here's negative pi. All right? So the triangle I'm going to be looking at is going to be, I like to think about it, oh, my pi went away. I like to think of this as an infinitely tiny rectangle, or excuse me, triangle, where this is theta right here. And so there's theta right there. And let's see, this has a height of 0, hypotenuse, which I put on the top. It's kind of hard to tell, hypotenuse of 1, and a adjacent of negative 1. Okay, let me get rid of this theta. Get that theta out of the way. So the cotangent of negative pi is going to be equal to, over here I said adjacent over opposite. So the adjacent is negative 1 over opposite. What's the opposite? It's 0. Well, dang. Remember what happens when we divide by 0? Well, I'll tell you what happens when we divide by 0. Math breaks. So in this case, the cotangent of negative pi is undefined. Well, I'm good at spelling. Defined. Good thing I'm not your language arts tutor. Undefined. All right, that matches what they instructed us to do right here if the expression is undefined. Write undefined. All right, cool. All right, fantastic. Not too bad, huh? All right, let's go ahead and go on to the next problem, Hunter. All right. Use a calculator to find each value. Oh, now I have to break out my calculator. Round your answers to the nearest thousandth. So let's see. Depending on, let's see. You've got the TI 84 CE. So let me look up a picture of your buttons. TI 84 CE buttons. All right, images. Show me the images on your TI 84 CE. That's close, but I want all the buttons. All the buttons. That might not do it. I want a close-up of those buttons. Maybe this one will work. Nope, can't see it. Maybe this ain't going to work. Hey, that's what I want right there. All right, so let me just copy this so I can see it. Oh, come on, you can do it. All right, there we go. All right, let me see this. All right, so here's my fancy schmancy calculator. I'm going to move this guy around. All right, now, using our calculator. Well, right now in our calculator, we don't have any secant or cosecant buttons, right? So we're going to have to use the reciprocal identities. So let's see. First thing we're going to evaluate is the secant. This is problem number 3. The secant of 2.5, that's radians, right? They didn't put the degree sign, so that's 2.5 radians. Well, shoot, with the calculator, geez. Don't I know that the secant is the reciprocal of the cosine? Now, if you don't remember that, go ahead and look back in the video to find that. But it's equal to the reciprocal of the cosine of 2.5. So what you need to put in your calculator is this. That should give you the secant of 2.5. Let's see if I can press those buttons. First thing you're going to press is this guy, right? Well, I would do it in the fraction form. So, geez, it's been so long since I used this kind of calculator. How do you do fractions on this puppy? I don't know, but you can figure it out. Let's see. Man, I don't know. I don't know how you do fractions, man. I don't know how you do fractions. N over D. Isn't there an N over D? Nah, whatever. Who cares? All right, you can do this fractions. That's going to piss me off if I don't know how to do it. All right, I don't see it. Whatever. It's all right, but you're going to use this sign button right here, and you're going to make sure it's in radian form, like it says up here, radians. You're going to use this sign button. You're going to use the 1, and you're going to use the fraction button if you can find it. It looks like I can't. And then you're going to put in 2.5. 1 over cosine of 2.5. If you don't want to put it in with your fraction pretty print, you'd have to do this. 1 divided by parentheses cosine 2.5 radians, 2 close parentheses, which is what I have to do because I don't have a pretty print calculator. So let me just throw that in the calculator, see if we get the same answer. 1 divided by the cosine of 2.5. I hope I'm in radians. Let's see, enter. Let me just double check if I'm in radians real quick. Yeah, I'm in radians. All right, so I put this into my calculator, and my answer was this one, negative 1.24822. And your calculator might have got something a little different down here because each calculator, in fact, doesn't exactly evaluate it. It's always a numerical approximation in a calculator. So those might be a little bit different, but the number is pretty much the same. In any case, they're asking us to round to the nearest thousandth place. So let's see, how do we round again? So let's see, this is the tenths place, this is the hundredths place, now here's the thousandths place. That's the last digit that I want to keep, so I got to chop everything else off. Before I chop it off, I got to check if the next guy is a 5 or greater, in case I need to round up, but I don't, so I round down, And I am left with my answer after rounding, negative 1.248 is equal to the secant of 2.5 radians. That's my answer. I hope you can do the same thing. Now I'm going to let you go ahead and try to do the next one on your own. Go ahead and pause the video right now, Hunter. See if you can do it all on your own. Use the cotangent reciprocal identity with the tangent, and you'll be able to do it, my guy. You'll be able to do it. Alright, did you pause the video? Because if you didn't pause the video, pause it now, dude. Anyway, I'm assuming you paused it and tried it on your own. Now I'm going to try it real quick. Cotangent of negative 32 degrees. Did you switch your calculator to degrees mode? That's going to be equal to 1 over the tangent of negative 32 degrees. So let me put that in my calculator real quick to see what we're doing. All right, I got to change it to degrees mode. All right, perfect. If you don't know how to change your calculator to degrees mode, I think you have to go into the mode menu, which is right there, and you'll find it somewhere. All right, 1 divided by the tangent of negative 32 degrees. For me, it spits out, oh, well, hold on a second. It's going to be negative 1 over the, okay, got it, okay. All right, I want a numerical approximation here. How do I get a numerical approximation here? All right, this is what I got. My numerical approximation is negative 1.60033, and I'm sure it goes on. All right, so we got to round to the nearest thousand. I hope I did that right. I am not so confident I did that super right in my calculator. But, you know, that's just calculator stuff. All right, so here's the thousandth place. We're going to chop off everything after the thousandth place. Before we chop it off, we got to check if this leading digit is 5 or greater, but it's not. So they go away. And my final answer is negative 1.600. And you should include those zeros because it shows that you've gone to the thousandth place of accuracy. If you chop them off, then somebody might say, oh, you rounded to the 10th place, but we didn't. We went to thousandth place of accuracy. Now, I'm just going to go and double check to see if I got that number right. So I'm going to go back and just throw this into Google, and I'm going to say, what was my, so I'm going to go tangent of negative 32 degrees. See if it gives me that. Tangent of negative 32 degrees. Man, Google didn't get the same thing I did, man. Oh, that's because we're doing the cotangent, right? Yeah, the cotangent. Okay, you can't handle the cotangent, so what we're going to have to do is 1 divided by the tangent of negative 32 degrees. Oh, man it. There we go. There we go. Yep, okay. It agrees with me. 1 over the tangent, yeah, we got that in Google. Perfect. All right, man, let's go on to the next one. All right, graph each function in the interval from 0 to 2 pi. Now, I got a question for you, my guy. How the heck do we graph a function? I mean, the sine function was easy. I taught you how to do that, but what if I give you this super complicated function and you don't know how to graph it? What's a good place to start? Well, the good place to start is just to throw in some points to see where they are, okay? So let's see, graph each function in the interval from 0 to 2 pi. Now these are going to be awesome. I wonder if you can use your graphing calculator for this. I think you can, but I'm not positive. We'll check them with our graphing calculator, see if we got them right. So here's my grid. Here I'm going to graph f of x, or f of theta, is equal to secant of 2 theta. Isn't this 1 over the cosine? Excuse me, yeah, a 1 over the cosine. So f of theta is equal to 1 over the cosine of 2 theta, right? Now, this is going to be interesting what I do up here. So let me graph 1, 2, what is the interval I have to graph it on? 0 to 2 pi. Alright, so I have to graph it on 0 to 2 pi. Right now, what I'm going to graph in red is just the cosine function, cosine 2 theta from 0 to 2 pi. Alright? So it starts up here, because I don't have any vertical shift, don't have any horizontal shift. All I have is 2 cycles between 0 and 2 pi. I didn't do it perfectly, but I hope you understand, because drawing by hand, that's just how it works. So here's 2 pi, here's 1 pi. Yep, and looks like right here might be pi halves. Right here is going to be 3 pi halves. Nailed it. Now I want you to think and consider. Now I'm going to draw in blue the reciprocal, oh my gosh, in blue, I'm going to draw in blue 1 divided by the cosine. Okay, let's just throw in some points. Let's start with x equals 0 here on this vertical line. With x equals 0, the cosine of 2 times 0 is the cosine of 0. So the cosine of 0 is 1. Yeah, well, I mean, I can see that on my graph in red right here. So 1 over 1 is going to be 1. In fact, at any point on the graph where I have 1, it's the reciprocal of that graph is going to be 1 over 1, right? Same thing is going to apply at negative 1. When my cosine of my angle is equal to negative 1, then 1 over negative 1 is negative 1. So my, oh my goodness, my secant graph is definitely going to pass through those blue points, right? Now let's imagine what happens, where do we want to go next? Let's imagine what happens when theta is such that cosine of 2 theta is 0. In this case, this is going to be pi halves. Excuse me, not pi halves. This is going to be pi over 4. So at pi over 4, can I write this down? Cosine of 2 times pi over 4. Well, the cosine of 2 times pi over 4 is equal to the cosine of pi halves, and the cosine of pi halves is 0. Now, if I put this into there, I'm going to get that the secant of 2 times pi over 4 is going to be equal to 1 over 0. Take a minute to look at that. Work that out by yourself. Now, 1 over 0, math breaks again, doesn't it? Remember what happens when we get something like this? It's undefined, right? It's undefined. That means I'm going to draw a dotted blue line down pi over 4. And I'm also going to draw a dotted line everywhere where the cosine intercepts the x-axis. I'm going to do this because I know the secant is undefined at these locations. The secant is 1 divided by the cosine, and the cosine at these places is 0. So the secant is 1 divided by 0, and that's undefined. Well, shoot. Boy, look at that. Dang. Okay, boy, that's a lot of information to handle right now. But we still don't know what the graph looks like, so we have to try a few more values. In fact, we can figure out just one cycle, right? And then we can figure the rest of the cycles out. So, let's figure it out. Well, maybe we can do it graphically. 1 divided by 1 is 1. And 1 divided by something a bit smaller than 1 is going to give us what? What is this? This is the same as 1 over 9 over 10. which is the same as 10/9. So if I put in a number that is a bit smaller than 1, then I get out a number a bit bigger than 1. That make sense? This is happening when the cosine is near 1 at these places. So 1 divided by those numbers is a bit bigger than 1, isn't it? So I know from here it's going to go up. In fact, if you think about 1 divided by a really small number, like this, like we did the other day, as you start evaluating the secant, when the cosine approaches 0, the secant is going to blast off without bound on the left and the right. Pretty interesting, huh? You can think about it the same way. 1 divided by a number pretty close to 1 is still pretty close to 1. But divided by -1 is going to be negative, so these are going to point downwards. And 1 divided by a number that's really small but negative is going to be a huge negative number. So that's what the graph is going to look like down here. And over here, we can already tell what the cycles are going to be. Up here, it's going to look just the same as the other one. Going up with one asymptote, coming down just like this. So right now what I have in blue is the reciprocal of the cosine function. Or in other words, it's the secant of 2 theta. Now, of course, I don't even know if we had to do that by hand, so let's check and see if the graphing calculator agrees with us. Let's go to GeoGebra. Alright, here we go. Start graphing. Okay, I hope it's already in radians. If not, I'm going to be very sad. Alright, here I'm going to have f of x, please make it red, is going to be equal to the cosine of 2x. Alright, I made it green. Oh well. I'll make it red here in a second. Not that this matters much. There, red. Nailed it. Alright, now I'm going to make another function, and this is going to be equal to the secant of 2x. And please make it blue. Oh yeah, I made it blue. So now we're just going to examine between x equals 1 to x equals 2 pi. So that's about here to about somewhere around here, right? So did you think we got it right? Here on the screen we have 2 cycles before getting to 2 pi, and you know, at every maximum of our cosine function we have a minimum of the secant function, and it points upward here and there and there, just like we have on our graph. I think we did this right. So let's compare and contrast. What do you think? This is what we have. This is what GeoGebra tells us. You think we did it pretty good? I think we did it pretty good. We nailed it. All right, good work, my guy. We might come back to GeoGebra for the next one, but hopefully this one won't take as long. Now, let's see. We see that the secant graph is cyclic, just like the cosine function. In fact, it has the same period. The secant is going to have this many cycles crammed into 2 pi. Now, there's no such thing as amplitude of the secant, because the amplitude would be the maximum minus the minimum, but in this case, the maximum, well, there is no maximum. It just blasts off to infinity. So whatever number you think might be the maximum, I can find one bigger. So there's no maximum. All right, not too bad. Was that all of it? That's all we had to graph? Okay, that's all we had to graph. All right, next problem. All right, next problem. Let's get rid of that. Okay, not too bad, not too bad. Let's do some more. Graph each function in the interval from 0 to 2 pi. Number 6. Y equals cosecant 2 theta minus 1. Okay, so the minus 1 is a vertical shift, isn't it? So we'll think about that vertical shift in a second. The cosecant is equal to 1 over the sine of 2 theta. Well, I mean, cosecant of 2 theta is equal to 1 over the sine of 2 theta. And then we have the minus 1 on the outside, don't we? Okay. So let me do what we did last time. I'll draw the sine graph in red, and then I will draw the reciprocal of that graph. So we're going to have a center of -1. That's a vertical shift of down -1. And now I'm going to have 2 sine cycles between 0 and 2 pi. So here's 2 pi. Right here, that's pi. Here's pi over 2. And I didn't graph this exactly right, you know, because let me try this one more time. This should reach all the way up because its amplitude is 1, isn't it? Alright, so this should go all the way up and then down. Not quite like that, though. It's going to go all the way up here, then down, then up, then down, then up. There we go. That's what I wanted. How does that sound? Where this is -2, this is -1, and this is 0. Alright, now my amplitude is 1, just like I wanted. Now, again, this is only the sine part. This is not the reciprocal of the sine. Now, in blue, I'm going to draw the reciprocal of the sine to get my cosecant. Alright? And it's exactly like we did before. Let's check it. Right here, I'm going to have an asymptote, just like I did with the secant graph that we made a moment ago. And this is going to be pi over 2, so, you know, fudge that line, make it sure it passed through pi over 2. Right here at pi, it's going to have an asymptote also. Right here at 3 pi over 2, also an asymptote. And here at 2 pi, it's going to have an asymptote. Now, I'm going to ask you a question. Why doesn't it have an asymptote here? After all, our function equals 0 there, so if you take the reciprocal of the function, wouldn't it have an asymptote there? Wouldn't it break there? Well, not quite. The reason not quite is because this -1 is after we apply the trig function. Okay? If we put in pi halves to sine of 2 theta, then we're going to get sine of 2 times pi halves, which is equal to sine of pi, which is equal to 0. So this thing would be y equals 1 over 0 minus 1. So it breaks at, at pi over 2. It does not break here. It does break at pi over 2. Okay? So we do have our asymptotes in the right place. Good question, Hunter. Alright, now all I got to do is I got to do the same thing that I did before. I got to graph the reciprocal of this function. Okay? And graphically, this is what it's going to look like. Of course, when you graph this, you should either draw very faintly the sine, the thing I have in red, you should draw that very faintly so that people don't think it's part of the graph, or you should draw it and then erase it after. So what I have in blue now is cosecant of 2 theta minus 1. Minus 1 being the vertical shift downward, and the 2 being the number of cycles being crammed into 2 pi, right? Right now my period is pi because that's the width of one cycle. Okay? Now, I think we should let GeoGebra check us one more time. So, let's let GeoGebra check us. Let's see if I can delete this function and make a new one. F of x is going to be equal to, what are we doing now? We're doing sine of 2x minus 1. And here I want to have g of x be equal to 1 divided by, well, no, I think I could put in cosecant here. Cosecant of 2x minus 1. All right, let's see what GeoGebra thinks about us. What do you think, my guy? Isn't that about right? I think that looks exactly like what we have. But take a moment to convince yourself that this is right, and then we'll move on to the next problem. All right. Oh, next problem. Done with the graphing. That's not too hard. All right, let's do this one. Use the graph of the appropriate reciprocal trigonometric function to find each value. Round to 4 decimal places. All right, so this is just some graphing calculator shenanigans. So you're going to have to put this, to find this with your graphing calculator, it says use the graph of the appropriate trigonometric function to find each value. Let me switch to black. So to do this, you're going to need your TI 84 Plus Color Edition, which you are so lucky to have. All right. So what you're going to do is you're going to go into your y equals editor, which is this box right here, your y equals editor. That's the button you're going to press. And then you're going to go to your y1 line, which I think is blue. It's usually blue. Or maybe it might be red. It depends on what you've made it. And in the y1 function, you're going to put cosecant of theta or x. You just put x is fine. Now, before we do this, I want you to make sure that you switch your calculator back to, let's see. No, actually, take a look here. They want it in degrees, right? So we should keep it in degrees. All right, now after you fiddle with your y equals editor, we've got to fiddle with the window. And the window is it's just the area that I'm looking at. Now, I want to be able to go up to x equals 130. So why don't we graph it from x min is equal to, I don't want to do 0. I want to do just a little bit less than 0. Put minus 20. And then we'll go x maximum is going to be equal to, say 200 degrees. Let's see, our y values, who knows how big our y values need to be. Let's start with y min, going to be equal to, I don't know, -5, and y max equal to +5. That might work. That might not be sufficient, though. If it's not, you can come back and change it. And we'll have our y step equal to 1, or y scale. That means the same thing. And our x scale, we can have that equal to 10 or 20. I think 10. 10 will be fine. Okay. Nothing that I recall is nothing more that we need to mess with in the window editor. So now all we've got to do is hit the graph button, and it should graph it for us. All right. So let me go ahead and graph this in GeoGebra. I hope I can. All right, delete that puppy. Well, all right, I guess not then. All right, let's graph this guy. Let's put, I don't know if I can put it in degrees, so I'll just put cosecant. So f of x is equal to the cosecant of x, and then I'll go settings, and I'll go advanced, well, geez. Okay. All right. Settings. I don't even know if I can do this. Well, I don't know if I can switch it to, I don't know how to switch it to degrees. I'm sure you can, I just don't know how, which is unfortunate. I guess I'll have to figure that out. But I'll put it into my graphing calculator real quick to see what I get. And I'll give it with the exact same scale and everything. Just give me a few moments to figure that one out. All right, so I've got cosecant of x. When I have to put it into calculator, I have to put it in as 1 divided by, what's the reciprocal of cosecant? It's sine of x. So that's how I have to put it into my calculator. 1 divided by the sine of x. Alright, nailed it. Now I gotta switch to degrees mode. No, I'm already in degrees. That's good. Okay. Alright, now I got to go to my window editor. Alright, my x-min, what did I say my x-min should be? Negative 20. X-max should be 200. X-scale should be 10. Y-min, negative 5. Y-max, 5. And then Y-scale should be 1. Perfect. Now I'm going to go ahead and graph it. Alright, this is what mine looks like. I'm going to try to draw it up here on your TI. This is what mine looks like. Those are the axes. And this is what the graph looks like a little bit. I get this little piece down here, and then I get a dip, and then I come back up on the other side. That's what that's what mine looks like. So, whew, okay, that's not too bad. We're just graphing it. We're just graphing it. No problem, no harm, no foul. Now let's take a look at. Let's take a look. How do we figure out the function value for this guy? We've got to use this second button. Press the second button, then press calculate, and you should get a menu. You should get a menu that has a certain number of options, and I don't remember which one it is. I think it's the first one that says value, but I don't remember. You just press second calculate and scroll down to click the one that says value, and then you're going to see instructions in the lower corner of the screen, you know, that says what's the x value that you want, and we're going to type in using the number pad 130, and then we're going to press enter, and then it'll put our little cursor wherever it needs to go, and it will tell you the y value. So let me figure out how to do that in my calculator real quick. Alright, so for me, I've got to press F5 value. Okay, I'm going to evaluate at x equals 130, and my y, when x equals 130, my y value is equal to 1.30541. I hope you got something relatively close to that, because each calculator is just slightly different. Now we've got to round to 4 decimal places, so 1, 2, 3, 4, chop that off. It's less than 5, so we don't need to round up. There's my answer. Alright, so this is just part 1, so I can upload it in smaller chunks. I'll be back in just 1 second.